Hi everyone, this is Python Osmosis, episode 49, the screencast that shows you that choosing a list is not as always as simple as it sounds. I'm Ryan Shea, and in this episode we'll be talking about the standard library, tools for working with lists. So it turns out that there's a few alternative data structures in Python for dealing with lists that don't conform to the standard way that lists work. If you know that you have certain memory constraints, a great choice for you may be array. Array is essentially a list, but all of the types within that list are of the same type. In a standard list, you can have integers, booleans, floats, everything can all be in the same list. But let's take a look at a different example. From array, import array. In this case, we're going to create an array that's made up of H data type, which is 2 bytes or shorts. And then in that array, we're going to put 4,000, 10, 700, 22, 222. So if you know that your data is all going to be integers that are only less than a short, which is 2 bytes, then you can go ahead and save on memory. And especially if you have large lists, you can save a lot of memory by creating an array. Now if you look, and if I hit .tab, it has the same sort of things that a list has. It has item size, insert, reverse, remove, count, extend, all the things that you'd expect to see with a list. And if we do that, let's do a sum of all of the pieces in it. Sum A. Okay, so it works just fine. And you can also do slicing. A, 1, 3. Okay, so you see that you get H back, you get an array object back. And so that array object has to specify that, no, instead of using the 16 bytes that typically represent a single entry in a list, we're only using 2 bytes. So yeah, it can be much more efficient. Another type list-like thing is called a collection, and we're going to use the DQ module in collections. So if you're using your lists as a queue, and effectively you're doing pops from the left side, you're always popping something off the left side, DQ can be a more efficient way of doing that. Let's take a look. D equals DEQUE, and then in here we're going to put task 1, task 2, task 3. So this is effectively our queue, and we're always going to be working from the left. And then D.append task 4, so you can treat it kind of like a list. And that way, add to the end of the list, print, handling, D dot. Pop left is the method that's particularly efficient. IPython is doing some funny things here where it's rewriting my print statement to be the new style print statement, but that should actually just print handling task 1. Another way of dealing with data. This is different than a list implementation, but a way of dealing with a list. This is called bisect. Import bisect. And what this is going to do is let you take sort of a sorted list and just insert something into it without having to resort. So let's say you had scores equals, and you had this sorted list, and it's a list of tuples. Okay, so you see that it's sorted by the scores, 100, 200, 400, 500, which is element 0 of each of the member tuples. So it's sort of an expensive operation, especially if this is a very large list, to insert something into the middle of it that might have a score of 250 or 300, because now you're going to have to insert it at a certain location, then you're going to have to resort that out. So what you can do is bisect.insort is the method, and then you can say scores. I want to insort into scores this new thing, this new tuple 300 ruby. Okay, and now scores. I sort of skipped having to resort that list. It did it for me. So it's particularly optimized for that purpose. Another thing you may be interested in is called Heap Q. So let's take a look at that. From Heap Q, import heapify, heap pop, and heap push. What this is particularly useful for is applications where you repeatedly access the smallest element, but don't want to have to resort every time. So let's pop some data into a list here. So there's a bunch of data, and it's not sorted. I can run heapify, which I imported from Heap Q, on that data. And if I do, that effectively rearranged the list into heap order. Heap push data, data -5, this is going to add a new entry onto that heap, that heapified list. And then now if I do a list comprehension here, heap pop data for I in range 3. So again, like I said, if you're continually trying to get the three smallest things, so heap pop is going to pop off that smallest one, and this is going to give us the smallest 3. And there you go. There's a list of the smallest 3. Nice and efficient. That's all for now. This screencast is directly inspired by the official Python tutorial by Guido van Rossum at python.org.